Before we continue, let's just do a quick review of waves and some of the components of a wave. As you can see right here, this wave is a sinusoidal function. It's moving up and down, kind of like, the waves on a seashore or sound even. So the distance from one crest to another, or even one trough to another, is known as the wavelength, or the distance that it takes for it to go for one cycle. In this particular wave, we can see that the wavelength is relatively small, but the frequency, the number of times it occurs, let's say over a second, is high. And so what that tells us is that there is an inverse relationship between the frequency, and I'll signify that with the f, and a wavelength. So for example, let's say I took a totally different wave that was just much larger, like this. Over here we can see that the wavelength is much bigger. I'm just calling this 1. I'll call this lambda 2. We can see lambda 2, or this wavelength, is much larger. But what we also notice is that the time it probably takes to go from here till it reaches here is not that fast. So this is what we mean by the inverse relationship between the wavelength and the frequency. The larger the wavelength, the longer it takes, so the lower the frequency. Whereas in the first one, we can see it's a shorter wavelength, but it's a larger frequency because it means that it hits a certain point more times or is more frequent.